Hello friends, Mr. Burrell here. We're going to start today's lesson, which is talking about something called synthetic division. So by the end of this lesson, hopefully you're able to divide polynomials using something called polynomial synthetic division. And hopefully dividing polynomials is something that you've heard before. We've talked about polynomial long division already. But before I comment on that, let's talk about / review all the things we've talked about so far associated with polynomial functions. Okay, we've been spending a lot of time in the last several lessons talking about factoring and solving different kinds of polynomial functions. Okay, way long time ago / maybe you reviewed it in this stream of lessons as well. We talked about quadratic functions and how you can use factoring as a method to solve quadratic functions, and we can use the quadratic formula as a method for solving quadratic functions. Remember that quadratic functions are ones that look like this, where they are a degree 2 polynomial. And we had some methods in our math tool belt for solving quadratic functions. This unit, in these units, we've been talking about solving higher degree polynomials, cubic polynomials, quartic polynomials. What about quintic, 5th degree polynomials? What do I do with those? Because the methods that I use for quadratics don't work anymore. So we talked about a variety of things. Okay, we talked about long division, which we're going to review in just a second, as a way to break down a larger polynomial, like a cubic or a quartic polynomial, into a smaller degree polynomial, like a quadratic, that I then have tools in my tool belt with which to solve. Okay, we talked about factoring by grouping. If I have a polynomial with 4 different terms, how I can group 2 terms together and kind of factor in groups. That's what's called factoring by grouping. We talked about factoring quadratic type polynomials, where they were 4th degree polynomials instead of 2nd degree polynomials. And we talked about ways to factor quadratic type functions, still using our quadratic factoring methods, but adjusting them a little bit. Okay, we've talked about sum and difference of cubes formulas, how I can factor polynomials that are expressed as a sum or difference of perfect cubed terms. Okay, we've talked about lots of different methods for dealing with polynomial functions. Okay, so today we're going to be talking about something called synthetic division, which isn't really another method. It's just kind of almost like a shortcut, I would say, for polynomial long division, of which you've already learned about. So before I show you how to use synthetic division, let's rewind a little bit. I have a traditional long division problem, n cubed plus 14n squared plus 53n plus 72 divided by n plus 9. Just to make sure we're all on the same page, let's use polynomial long division to divide n plus 9 into this cubic polynomial. Remember, using long division, here is my divisor, n plus 9. So I'm going to divide n plus 9 into this long polynomial, n cubed plus 14n squared plus 53n plus 72. Okay, so let me walk through just briefly and remind you of the steps associated with polynomial long division. So first, I need to see what I can multiply by n to get n cubed. What is n divided into n cubed? Well, that's going to give me n squared, because n times n squared is n cubed. I'll go ahead and write that up on top of my division symbol above the other n squared terms, so they can all stay in place. Then I'm going to multiply n squared by this binomial divisor, n squared times n plus 9. So n squared times n is n cubed. Let me put that down here underneath the other n cubed. N squared times 9 is 9n squared. Let me put that down here underneath the other n squared. Okay, that's the second step, is I multiply n squared by my divisor. Then I'm going to subtract that divisor by from my original dividend here. So n cubed plus 14n squared minus n cubed plus 9 squared is going to turn into n cubed minus n cubed and 14n squared minus 9n squared. Whenever I subtract polynomial terms, the signs change. So n cubed minus n cubed is 0, which is what I want. Then 14n squared minus 9n squared is 5n squared. Okay? Then I'm going to bring down this next term, 53n, and I'm going to start the whole process over again. So to finish this problem, I'm going to go a little bit faster. What do I multiply by n to get 5n squared? Well, I multiply by 5n, because 5n times n is 5n squared. 5n times 9 is 45n. When I subtract these, this changes to a negative, this changes to a negative. 5n squared minus 5n squared is 0. I like that a lot. And 53n minus 45n is 8n. I'm going to bring down the next term, which is a positive 72, and start over again. What can I multiply by n to get 8n? Well, 8. 8 times n is 8n. 8 times 9 is 72. Boop. When I subtract these two polynomials, both of these terms are going to change to negatives. 8n minus 8n is 0. I like that. And 72 minus 72 is also 0. I like that even more. If I would have gotten a number here, that would be my remainder, and I would have to add that remainder at the very end, divided by my original divisor, n plus 9. But in this case, this is my final answer, n squared plus 5n plus 8. I divided this cubic polynomial by a linear, or first degree binomial, and I ended up with a quadratic, n squared plus 5n plus 8. Notice that my answer here is 1 degree less than what I started with, okay? And then maybe you'd be instructed to, I don't know, set this equal to 0 and solve for n, for which you can't factor this quadratic. You'd have to use the quadratic formula, etc., 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 etc. That's great. That is old news, though. We know how to divide two polynomials using polynomial long division. Okay? Let's talk about something called synthetic division. Okay? Synthetic division is just a shortcut method that I can use in the place of polynomial long division. Okay? So let me show you what synthetic division looks like, what the little shortcut algorithm looks like, and then show you and explain some of the rules that we have to follow associated with synthetic division in order to actually get the correct answer. Okay? So when I'm doing synthetic division, let's take this problem as an example. 2x cubed minus 5x squared minus x plus 3 divided by x plus 3. So first I'm going to draw, instead of a traditional division symbol, I'm going to write like what looks like a big L. Okay? And at the top of that L, leaving space underneath for numbers, I'm going to write the coefficients on each of the terms in my dividend, in the polynomial that I am dividing. Okay? So you'll see I have a 2, negative 5, negative 1, because there's a 1 in front of that x always, and a 3. So that's kind of the first little difference, first couple differences with synthetic division. I draw this big L symbol, and I'm going to write just the coefficients without the x's that are in front of each of the terms here at the top. So 2, negative 5, negative 1, and 3. Okay? The next big difference, out in front of my division bar, like if I was doing traditional division, I would write x plus 3. Well, instead of writing the whole divisor, I'm going to set that divisor equal to 0. And I'm going to use the 0 or the root or the solution associated with that divisor. So when I set x plus 3 equal to 0, I subtract 3 on both sides, and I get x equals negative 3. That's what I'm going to put out here in front of my synthetic division symbol. Okay, that's kind of part of the shortcut associated with synthetic division. Okay, then the process for dividing goes as follows. I bring down the first term, this first coefficient, and write it underneath the L, 2. I'm going to multiply negative 3, my root, or my solution over here, by 2, which gives me negative 6. I'm going to write that negative 6 up underneath the next term. So I have negative 5, negative 6, and I'm going to add those two numbers together. Negative 5 added with negative 6 is negative 11. Then I'm going to multiply negative 3 by negative 11, which gives me positive 33, and write that positive 33 up underneath the next term. So now I have negative 1 and 33, and I'm going to add those two terms together. Negative 1 plus 33 is 32. Then I'm going to do negative 3 times 32, which gives me negative 96, and write that underneath the next term, which was 3, and add them together. 3 added with negative 96 is negative 93. And there's no more terms over here, so I'm not going to do any more multiplying. I'm done. But I'm not done, because obviously this is not a polynomial. This is just a bunch of numbers. So now I'm going to have to rewrite my polynomial, put the x's back in, if you will. So note that I started with a cubic function, 2x to the third. I started with a third degree polynomial. My answer is going to be, since I divided it into a first degree polynomial, divided it by, a first degree polynomial, my answer is going to be 1 degree less than what I started with. So since I started with x cubed, my answer is going to be a second degree, or a quadratic polynomial, okay? This first number is the term on that quadratic term, on that quadratic piece. So my answer is going to be 2x squared minus 11x, I just go 1 degree down from there, plus 32, which is my constant. And then if there's a number here, that is what my remainder is. So notice I wrote plus negative 93 over then my original divisor, x plus 3. If this was a 0, that would just mean that there was no divisor. That is my final answer, 2x squared minus 11x plus 32 plus negative 93 over x plus 3. If I did decide to do polynomial long division, okay, I would end up getting the exact same answer. 2x squared minus 11x plus 32 minus plus negative 93 over x plus 3. I'd get the same answer. Synthetic division is just kind of a shortcut way to get that answer, okay? So let me highlight some of these rules I already talked about, but let me highlight some of the quirks and rules associated with synthetic division that I have to remember, that I have to use if I'm using it in the place of long division. First of all, placeholders must be put in the equation for any term that is not present in the original problem. So say, for example, I had 2x cubed minus x plus 3 divided by x plus 3, and I didn't have an x squared term. Well, if I do synthetic division, I would need to put a 0 in its place. So right here, instead of negative 5, there would be a 0. I can't just leave it out. I do need to have a placeholder for every single term from x cubed down to x squared, down to x to the first, down to the constant, etc., etc. Every degree term that would be there needs to have a placeholder. So that's one thing. Second thing, and I kind of already talked about this, instead of using the binomial to divide, I use the 0 or the root or the solution associated with that binomial. So instead of using like x plus 3, I'm going to use negative 3, because negative 3 is what I get when I set x plus 3 equals 0. Okay? And the last thing, and we're going to do an example of this in a minute, if the binomial divisor has a coefficient on the variable, it must be used to divide all coefficients in my answer again. So that's saying, if say I was dividing by 2x plus 3, instead of just x plus 3, then in my final answer, this is a theoretical right now, I'd have to divide every single one of those coefficients by that same coefficient. Okay, that's the last rule, and we'll do an example of that in a minute. So you might be thinking to yourself, there's like a lot of weird, quirky rules associated with synthetic division. Why would I choose that when I can just use long division? Well, some people prefer synthetic division at times because it's a little bit quicker. It is a shortcut if you remember all the rules. So let's do some examples, okay? The instructions here say divide the polynomials using synthetic division. So first thing I'm going to do here is I'm going to write a big ol' L to use as my synthetic division fraction, division bar, if you will. And then at the top of this L, I'm going to write the coefficients on each of these terms. So there's a 1 here, so I'm going to write 1, negative 3, negative 36, and negative 27. Okay, that's the first step. Then, out here in front, instead of putting b plus 4 or just 4, I have to set this divisor equal to 0 to find what the solution would be, what the root would be. So I would, in order to get b by itself, subtract 4 on each side, and I would get b equals negative 4. So negative 4 is what's going to go out in front of you. Okay? Next, I'm going to start going through the process of synthetic division. So I'm going to change colors here. I'm going to bring this 1 down. I'm going to multiply negative 4 and 1 together, which is negative 4. I'm going to write that negative 4 up here underneath the next term and add those together. Negative 3 plus negative 4 is negative 7. Then I'm going to multiply negative 4 by negative 7. Negative 4 times negative 7 is positive 28, which I'm going to write up underneath the next term. Okay? Negative 36 plus 28 is going to give me negative 8. And then negative 4 times negative 8 is 32, which I'm going to write up underneath the next term. Negative 27 plus 32 is 5, and I'm finished. Kind of. I have the coefficients for my resulting polynomial, and I have a remainder. Here's my remainder. So, since I started with a cubic polynomial, my answer is going to be a quadratic polynomial. So this first number here, number 1, is going to be the coefficient in front of the quadratic term. So I'm going to have 1b squared, or just b squared, I don't need the 1, minus 7b, I go down from there, minus 8, that's my constant, and then plus 5 is my remainder, so I'm going to divide 5 by b plus 4, my original divisor. And that is my final answer. B squared minus 7b minus 8 plus 5 over b plus 4. Okay? If I used polynomial long division to do that problem, I would get the exact same answer. But again, if I remember the rules, synthetic division can be a little bit quicker. Okay? Let's do another example. Note that this is the same example that we did at the very beginning when we were reviewing long division. So now let's solve this. Let's divide these two polynomials using synthetic division. So I'm going to go ahead and write down the coefficients for each of these terms, 1, 14, 53, and 72. And then in order to get what number goes out here, I'm going to set n plus 9, which is my divisor, equal to 0. Subtract 9 on both sides to get n by itself, which gives me n equals negative 9. So that's what's going to go out here. Okay, so now to go through my synthetic division, let me change colors one more time. I'm going to bring the 1 down, which is 1. Negative 9 times 1 is negative 9. 14 added with negative 9 is 5. Negative 9 times 5 is negative 45. Write that up here. 53 plus negative 45, or 53 minus 45, is 8. Negative 9 times 8 is negative 72. 72 added with negative 72 is 0. I like that. I kind of like when I don't have a remainder. So then my final answer, 1, is the coefficient on the first term. And since I started with a cubic function, my resulting answer is going to be a quadratic function. So I'm going to have 1n squared, or just n squared, plus 5n plus 8 with no remainder. So that is my final answer. And if I were to go back here, n squared plus 5n plus 8 is indeed what I got when I divided those two polynomials using long division. So both methods are perfectly acceptable. Both methods will give me the correct answer. Okay, that's synthetic division. Let's take a look at one more example. Notice any differences about this problem. Notice that this term that I'm dividing by, 6v minus 2, does indeed have a coefficient in front of the variable. This is a 6v minus 2 instead of just v minus 2. So I'm going to have to take some extra precautions here, okay? So let's write my synthetic division bar here. I'm going to write the coefficients on each of these terms. Okay, 6, negative 20, negative 42, and 16. Notice I haven't been putting the plus signs in front of each of these. You absolutely can. It doesn't matter. So then to get what's going to go out here, I have to set this divisor equal to 0, find the 0, find the root. So I'm going to add 2 to both sides. And note that a lot of people will stop at that. They'll be like, okay, 2, that's the number that goes out in front. But note, in order to solve for v, I still have to divide by this coefficient. I have to divide by 6. So v equals 2/6, or 1/3. That's what's going to be the number out here that I'm going to be dividing. Okay, so let me change colors one more time. I'm going to bring the 6 down. 1/3 times 6 is 2. A lot of people don't like those fractions, but the process is still the same. 1/3 times 6 is 2, or 6 divided by 3 is 2. Negative 20 plus 2 is negative 18. 1/3 times negative 18 is negative 6. Negative 42 plus negative 6, or negative 42 minus 6, is negative 48. 1/3 times negative 48 is negative 16. That's convenient because 16 plus negative 16 is 0. I like that. Okay, so the tendency for a lot of people will be, this is not the right answer, but this is what I'm going to write down. To write their answer as 6v squared minus 18v minus 48 with no remainder. Okay? But the dilemma with that is, remember that when I'm doing synthetic division, one of our little quirky fancy rules is that if there's a coefficient here in front of my divisor, I have to divide each of my resulting coefficients, not the remainder. It doesn't matter here because I don't have a remainder. Not the remainder, but each of the resulting coefficients by that original coefficient. So I have to divide each of these terms by 6. So this isn't my answer, but rather 1v squared minus 3v minus 8. That would be my final answer, my resulting polynomial. Okay? So, with that, hopefully now you can divide polynomials using synthetic division. Again, synthetic division is just a shortcut for long division. If you're like, I don't really vibe with synthetic division, you can always use long division. Or if you're like, oh, this is kind of handy, this is kind of convenient, don't forget how to do long division, but you can use synthetic division as a shortcut, time saver if you want, as far as dividing polynomials goes. So I hope that was helpful. Please let me know if you have any questions, and I hope you had as much fun as I did.